So now we're going to find the measurement of missing angles given some information about a right triangle. So for this first triangle right here, I want to find the measurement of angle D. So if I look here, I know the side DH is 5 and the hypotenuse is 13. So if I sit at that angle D, that means I know the adjacent side to me and I know the hypotenuse side. Adjacent, hypotenuse. Well, that's usually cosine, adjacent over hypotenuse. If I use arccosine here, because remember, arccosine gives me an angle, I could actually find my missing angle. So the measurement of angle D would be equal to arccosine of adjacent over hypotenuse, so 5 over 13. It does say to give my answer in degrees, and it even says to the nearest degree. So I want to know what arccosine of 5 over 13 is, so I'm going to grab my calculator. First thing I'm going to do is check my mode. You click mode on your calculator, and then you scroll down where it says radian degree, and you want to make sure degree is highlighted. My degree is highlighted, so I'm good to go. Now I'm going to quit out of it so that I can enter my arccosine. We actually get to enter trigonometry into our calculator now. Well, if you look where cosine is on your calculator, you can hit second cosine, and that's where your arccosine notation's at. So now I've got arccosine in my calculator. I'm going to type 5 over 13 and make sure I close my parentheses for good measure. Hit enter. Woo! I get 67.3801, and it does say to round to nearest degree, so 67 degrees.
The next triangle we're asked to look at and find the measure of angle A. Well, if I'm at angle A, I look and I know the side opposite angle A is 4. I also happen to know the hypotenuse, which is 10. So I want to see which trig function I should use. Because I know the side opposite and hypotenuse, I want to use sine. Sine of angle A equals 4 over 10. And of course, now I need to solve that for the angle measure, so I'm going to take the arcsine of both sides and have theta equals the arcsine of 4/10. Let's plug that into our calculator. It ends up 23.578 and so on. Rounded to the nearest degree, 24 degrees. Squiggly equals about 24 degrees. Last, let's look at and find the measure of angle N in our third triangle. This time, we happen to know the side opposite is 9 and the side adjacent is 5. We don't know the hypotenuse this time. That's fine because opposite adjacent is tangent. So the tangent of N equals 9/5. Take arctangent of both sides and we have measure of angle N equals arctangent of 9/5. Let's punch that one in. 60.94539 and so on. Rounded to the nearest degree, 61 degrees, approximately.
So, how would we use this in real life?
Well, I think we could use math to figure out the height of this tree. Okay, I'm going to stand 30 feet away from the base of the tree. Then I'm going to go ahead and use a clinometer, an app on our phone, to see what the angle of elevation is as I look to the top of the tree. With those two measurements and some trigonometry, I can figure out the height of the tree. Let's try. All right, so looking at my angle of elevation from my eyes to the tip of the tree is 64.9 degrees. Now let's do the math. Now let's take a look at the triangle we formed. I'm 30 feet from the base of the tree. That would be my side adjacent because I formed the right angle. Then looking up, my angle of elevation, 64.9 degrees. And I want to know the height of the tree. That's the side opposite. So I know adjacent, I want to know opposite, that's tangent. Tangent of 64.9 degrees should equal x, the height of the tree, divided by 30 feet. So now I'll have to solve for x. So I'll multiply by 30 on both sides. Let's see what that comes out to. I'm in degrees, so check your calculator and make sure you're in degrees currently. So 30 times tangent of 64.9 degrees is 64.043 feet. We're going to go ahead and use 64. We'll round it to 64. And then we have to take into the account that my eye level is not ground level. So we know from my eye level to the top of the tree is about 64 feet. So then I just need to add how tall I am from ground to eye level. And I'm about 5.5 feet from ground to eye level. Kind of tall. So that would be 64 feet plus 5.5 feet. So the tree is about 69.5 feet, 70 feet or so. Not bad.
Okay, so I'm sitting up here getting the cold shoulder from Sophie down there, and I'm wondering, could I figure out my angle of depression looking down at Sophie? So from my eye level down to Sophie.
All right, from the base of the chair to Sophie is 12 feet. And with the base of the chair up, I have a right triangle. So I need one more measurement, one more side length, and I'll be able to use trigonometry to get the angle of depression or the angle of elevation. All right, so now we have the length of this side, 12 feet, and I just need this length. So then I'll have a right triangle. From eye line to the base looks to be 7 feet and 4 inches. 12 inches in a foot, so 4 out of 12 is 1/3. So I have 7 1/3 feet from the height of the eye down to the base. And remember, this was 12 feet. So what can we do with that?
Okay, so if this little Sophie over here would just look up at me, I could use her angle of elevation because that's actually the same as my angle of depression. Those two angles are congruent. So if I know her angle of elevation, then I know my angle of depression. So from Sophie's perspective, I know the opposite side, which is the height, which was what, like 7 1/3 feet? And then I know the adjacent side, which is the base, which was 12 feet. So opposite adjacent, that's tangent. So if I want the angle, I'm going to use arctangent. So arctangent of 7 1/3 feet divided by 12 feet. That's 31.4295 ish, which we're going to go ahead and round to the nearest degree. So about 31 degrees. So if Sophie would look up at me, she'd only have to crank her head up 31 degrees. So I'm looking down at her at an angle of 31 degrees. That little stinker. I wonder what else we can use this trigonometry for. Perhaps to figure out the grade of the slope from shallow to deep end? Boys!
They used the string, they measured how far it was from where the slope starts till where the slope ends in the deep end. That measurement, when we brought it back up, was 12 feet 3 inches. 3 inches, so 3 out of 12, that's a quarter of a foot. So 12.25 feet. And that's the slope, so that's our hypotenuse. Then we came above and we measured this length, where the slope starts, where the slope ends. That was 9.5 feet. So we have two sides of a right triangle. We have the adjacent, we have the hypotenuse. So,
well, if I have the adjacent and the hypotenuse, that's usually cosine. Since I'm looking for the angle, I'm going to use inverse of cosine. So in my calculator, I would type in arccosine. After I check to make sure my mode is degrees, because that's the angle I'm looking for. Okay, and then what'd you say my adjacent side was again?
9.5 feet.
9.5 feet divided by my hypotenuse?
12.25.
12.25. And then I hit enter and I get 39.1486874. So about 39 degrees.
And what are pool regulations?
Well, they say that the slope of a pool from the shallow end to the deep end needs to be anywhere between 30 and 45 degrees. So we're right in that range.
Math.
Outside. Well, that was fun. Who knew math could be outside and fun?
Yeah, and they actually use this for real places.
Yeah, like all the time.
Construction.
Auto body shops.
Surveying.
Video games.
What about planes?
Literally all over the place.
Okay, and now you know lots about this.
Have a great summer!